Hey everybody, time to go through the Nifty 50 as fast as possible. So hopefully you got your pen or pencil ready and basically just copy down anything you didn't do. Even if you didn't do anything, just copy down everything. And we'll get through this as quick as possible. So let's get going. So slope-intercept form, hopefully you know that one. It's y equals mx plus or minus b. To find slope from a graph, I locate 2 points and think rise over run. And that's one way. We're going to talk about a bunch of different ways. So with this one, I could use this point and maybe, let's say this one right here. So this one you go up 3 and right 5. So the slope, which we use the letter m for slope, is 3/5. To find slope from an equation, I know that m is slope, like we just said, and the b, oddly enough, is the y-intercept, where the line goes through the y-axis. So for this one, the slope is 1/8, and the y-intercept is positive 19, so that's where it would go through the y-axis. Now, to find slope from a table, you need to find the change in y over the, or divided by the, change in x. Okay, and the way that looks, which we just, when I say it in class, I say y minus y, but it's technically y2 minus y1 and x2 minus x1. That just means take the y, subtract it from another y, do the same thing with the x. So for example, with this one, I'd say 290 minus 230 is 60. 20 minus 5 is 12. I'm sorry, 20 minus 15 is 5. I'm thinking a little bit of ahead. And 60 divided by 5 is 12, so the slope of that one is 12. If we wanted to write the whole equation, we know now that it's going to start off y equals 12x. If I just kept going, I should see that the next column would be a 0. And if I'm taking 60 away, 60 away, 60 away, the next one here would be 50. So that equation would say plus 50 at the back. Other words for slope are rate of change and unit rate. Okay, relationships that vary directly, we also say direct variation, are proportional. That's when you do y divided by x and you get the same answer every single time. Again, that means it's going to go through 0, 0, and it's proportional. When writing an equation of a proportional relationship in the form y equals kx, the k represents the constant of proportionality, but we're just going to say constant for that one. Okay, up to the top, number 8, or actually it's just the next page for you. On a graph, non-proportional relationships, linear relationships, do not go through the origin. Okay, that means they're going to have a y-intercept that's not 0. In a system of equations, that means when you have two different equations and they're graphed here, the intersection, which is right here in this case, and that's the point -1, -2, that is called the solution. Okay, that's the one point that those two equations would have in common. We're going to label these following proportional or non-proportional. So this one does not go through 0, 0, so non-proportional. This one, oh, I'm sorry, D equals 65t. That's another one. That is proportional. Okay, and the reason it's proportional is because it doesn't say plus something or minus something after that. This one, if we did y divided by x, we'd get 1/5. Y divided by x, 8/40 is the same as 1/5. And 13 over 65 is the same as 1/5. So this is also proportional. Over here, since this one says plus 2,000, that means it's non-proportional. It's not going to go through 0, 0. It's going to go through positive 2,000. This one, if I do y divided by x here, 45 over 65 ends up being 9 over 13. And then I did 30 over 45, I'd get 2/3. So that means different answers means that's not proportional. That is not going to be Proportional, it's not going to go through 0, 0. And the last one does go through 0, 0, so it is proportional. Okay. Turn the page. You should be on number 11 now. In a function, each input value is paired with only one output. And that means the x value does not repeat. When we describe functions, or we can describe functions as, and we just did this, so I'm just going to put the same thing instead of writing the whole word, proportional and non-proportional. Okay, and you can fill in the rest of those words later, trying to get through this as quick as possible. We can also describe them as linear, which means straight line, or non-linear, not a straight line. Most of the ones we deal with are linear. Circle the functions, okay? So again, this is where the x value does not repeat, and our input is our x. Okay, so 2, 4, 6, 8. Well, that is definitely a function. Okay, this one here, we got 3, 17, and then 3 again, so that is not a function. Okay, this one here, 0, 1, then we got the point 2, 4, and 2, 5. That means it's not a function. And again, we're circling the function, so we'll circle that one so far. This one, when we're looking at a graph, we're going to see if there's any points directly above and below each other. So since all these are on their own straight lines up and down, that means this one is a function. This one, we got 210, 412, 624, 48. So the 4 goes to two different numbers, so that means not a function. This one here, we got 7, 3, 8, 1, 9, 1, and 10, 2. Now the y value repeats, but that's okay. That means this is a function. Okay, this one down here, see how these points are directly above and below each other, here and here? That means not a function. And this one here, we got 2, we're just looking at the x's again, 2, 4, and 6. Y's don't repeat, so that is a function. Okay, up to number 14, or turn the page to number 14, or just the next page. Complementary angles are two angles whose sum is 90 degrees. Supplementary add up to 180. Okay, parallel lines that are cut by a transversal, as shown below. Remember that line is called the transversal. Okay, and when that happens, see we got angles 1, 4, 5, and 8. So 1, 4, 5, and 8. All those angles are congruent, or same measurement. And then the angles 2, 3, 6, and 7 are also the same measurement. Now obviously the 2, 3, 6, and 7 are much bigger angles. Okay, so maybe just as an example, maybe this is 140 degrees, that one's 140. Remember, these two have to add up to 180, so that means this one's got to be 40, this one's got to be 40, and so on, okay? So in this question, angle 3 and 6. Well, angle 3 and 6 are on the inside, and they're alternate, so they're called alternate. We're going to shorten these. Interior. And then angles 1 and 8 are on the outside, and they're also alternate, so they're alternate exterior. Alternate exterior. Okay? The sum of the degrees of the angles in a triangle is always 180 degrees. Okay, down here, the sum of the two remote interior angles. So angles 1 and 2 are always going to equal this exterior angle. Okay, so let's say this is 80 and this is 60. Okay, if I add that together, I get 140. That means this one's 140. That also tells me that this last interior one is also 40. And again, all three of these will add up to 180. 60, 80, and 40 is 180. All right. Okay, number 19. Okay, in similar figures, corresponding angles are congruent. And the ratios, that means the fractions you can make, of the corresponding lengths are proportional. A figure and its dilations are similar figures. Remember, we don't really do any shapes that we change what it looks like ever. So we're going to have similar figures when we dilate shapes. The transformations that preserve congruence, that means the shapes stay the same size are pretty much all of the ones except for one. So translations, reflections, and rotations, we don't change the size. The only one that does not is a dilation. Remember, preserve means keep the same. So dilations do not preserve congruence. They change size. 21. The transformations that preserve orientation, that means they don't spin or turn. So those are translations and dilations. When we do reflections or rotations, we actually change the orientation. So those do not preserve it, but these two. So those are the answers for the next two: reflection and rotation. Reflections and rotations. So the rules when we write them: for a translation 4 units up and 7 units to the left. Remember, 4 units up, that's your y-axis. So if we're going up, it's y plus 4. 7 units to the left, that's your x-axis. So you're taking away when you go to the left, so that's x minus 7. Okay, for a reflection across the y-axis, that's the one where you leave the x alone, or I'm sorry, leave the y alone because you're going over the y-axis. So you just change the x. That's all you do. Same thing when you reflect across the x-axis, you leave the x alone and just change the sign of the y. Remember, that negative doesn't mean it becomes negative, it just means you change the sign. If it's positive, it becomes negative. If it's negative, it becomes positive. 25, for rotation 90 degrees clockwise or 270 counterclockwise. Remember, that's the only time when we actually flip the x and the y. And in this case, the x is the one we change the sign of. Okay, halfway through. Whew. Arm is going to be extra tired after doing this. All right, number 26. For a rotation of 90 degrees counterclockwise or 270, again, that's just the opposite of the one we did. So we flip the signs, and the y is the one that becomes a different, there we go, sorry, that was starting to get too dark there. The y is the one we change the sign of. For rotation 180 degrees in either direction, remember, 90 degrees is the only time we flip the signs, or flip the x and the y. These, we leave as x and y, but we change both signs when you go 180. For dilation with a scale factor of 3, again, scale factor, you just put the scale factor in front of the x and the y. When a figure is dilated by a scale factor, k, the perimeter is multiplied by k, and the area is going to be the scale factor squared, or k squared in this case. Okay? For this one, we got to figure out what they did and then write the rule. So for this one, this is a translation, which I'm just going to shorten, translation. And they took the x and the y, and they actually went 7 to the right and 5 down to get every point down to where it is. So that's the rule for that one. For this one, it's a dilation. And if we just take 1 point out here, this point right here is at 2, 1, and it went, I'm sorry, it's at, actually got smaller on this one. So it started out at 4, 2, and became 2, 1. So again, it's new divided by old. So the new ones are the small ones. So smaller numbers on top, I'd pick that one. 1/2 is your rule for that one. 1/2 x, 1/2 y. Okay, for this one, this is a reflection. And since they reflected it over the y-axis, that means you leave the y alone. So the rule for that one is you just change the sign of the x. This one is a rotation. They went 90 degrees, and they went 90 degrees this way. So it's 90 degrees clockwise. And the rule for that one, and if you just take 1 point, what happened to the r? Well, it was at -3. That's not a good one because the numbers are the same. Let's go to q. -3, +7. So that's where q is. And it became 7, 3. Okay, so as you see, they flipped the x and the y. And which one did they change the sign of? Well, the x was -3. So they changed that one. So that's where the negative sign goes. Okay, Number 30. So number 30, to find the mean absolute deviation, the MAD, you must first find the mean of the data, then find the absolute value distance each point is from the mean. So in other words, you find out how far away every number is from the mean. Absolute means no sign. It's not positive or negative, it's just the distance away. Then find the mean of those distances. Okay, so for this one, the mean, let me just do this real quick in my head, 5,466. I know the answers. So this one is 144 away, this one's 1,094 away, this one's 1,766 away, this one's 76 away, and this one's 892 away. And then you take those five numbers and average them, you get a MAD of 794.4. which is a pretty large number for a MAD. Those numbers are not really that close at all. You can tell just by looking. This person walked 6,500 steps. This person only walked 37. So those numbers are really far off. Okay, the Pythagorean theorem. A squared plus B squared equals C squared. For right triangles, the sum of the squares of the two legs equals the square of the hypotenuse. That's the C. Okay, always the longest line. So for this one, we've got 3 squared, which is 9, 4 squared, which is 16, and 5 squared, which is 25. To find the distance between 2 points of a coordinate plane, use the, and I'm just going to put PT for Pythagorean theorem. So for this one right here, okay, it goes from 10 to 280. That means it's 270. For this one, it goes from 20 to 164, so it's 144. Now, I'm not going to do all the math on this, but when you square these two numbers and then add them, and then find the square root of the answer, you should have got 306. Okay, to number 34, talking about some volume and surface area. To find the volume of a cylinder, the formula is V equals BH. Now, B is the area of the base. In this case, it's a cylinder, so the area of a circle is pi radius squared, so that's what the big B has to become. Now, to find the lateral surface area, lateral, again, that's the label, like the outside rim, you're going to use the formula 2 pi radius height. All you do is plug in those numbers, multiply them together. To find total surface area, well, the first part's the same, but then you got to add the area of those two bases, so plus 2 pi radius squared. Okay, to find the volume of a cone, we're going to use the formula, and this is a little bit weird, but it's 4/3 pi. Sorry, I almost wrote down the wrong one. My fault. Let's go back. I skipped the volume of a cone, is 1/3 big B times H. And again, the base of a cone is a circle, so that big B just becomes pi times radius squared. This is the one I meant to write next. The volume of a sphere, okay, like a soccer ball, baseball, something like that, is 4/3 pi radius cubed. And again, you just put this in the calculator. 4 divided by 3 times pi times the radius, it times itself 3 times. So radius times radius times radius. The calculator will do all that for you. Next, to find the lateral surface area of a prism, use the formula P times H, lateral surface area, where P is the perimeter of the base. Okay. Total surface area of a prism is PH plus 2B. Big B is the area of the base, and big P is the perimeter of the base. Remember, perimeter, you add up all the sides. Don't forget to do that. Okay. Number 41. Almost done. I need to be able to model and solve an equation. We'll talk about that in class here in a few days. Inequalities, okay, include less than, greater than, less than or equal to, greater than or equal to. I can describe the data on a scatter plot as linear, positive, negative, nonlinear, which means all scattered about, which is the same as no association. And you can make a prediction by drawing a trend line. Okay, label these. Okay, this one, positive. This one, negative. This one, none, no association. Going all over the place. Okay, the formula for simple interest, which we just did not that long ago, I equals PIT, where I is the interest, P is the, and we're just going to put money. I mean, it stands for principal, but let's just put money to shorten this down a little bit. And R is the rate, which is the percent. The T is time in years. Formula for compound interest, A equals P times 1 plus R in parentheses to the power of T. A stands for all, or total in the account. All in account, and that's a little bit different from simple interest. P is still the money. R is still the rate written as a percent. Remember, we got to change that to a decimal. And T again is the time in years. Okay, last page. I got to stand up. Real numbers include rational and irrational numbers. Rational numbers can be written as a fraction or a ratio. Every rational number can be written as a terminating decimal or a repeating decimal. Okay, examples, you can write any examples. Anything that you can write as a fraction or as a decimal or even one that repeats. Okay, those are all okay. Okay, irrational numbers you cannot write as a fraction. They're like square roots of something you don't know. You don't know the square root of 17. You'd have to estimate. It's like 4.1, but it goes on forever, okay? This right here, this estimating part means that it's irrational. When I compare and order decimals, compare and order numbers, I will convert them all to decimals. That's the easiest way to do it. Using my calculator and then putting them on a number line. Okay, pi squared is a little bit before 10, so it's like right there. 10.7, obviously right there. And the square root of 75 would be down here after 8.5. So now that they're in order, if you're going least to greatest, there's least and there's greatest. And lastly, to convert from scientific notation to standard or normal notation, negative exponents move the decimal to the left, and positive move their decimal to the right. Never add zeros. Remember, that's not how you do it. Okay, 23 minutes, about 2 questions a minute. I'm tired, you may be too, but hopefully you had as many of these as you could, and hopefully you wrote them all down. It's just a good study thing to look through for the next couple weeks, and if you're doing everything we're asking you to do, you should be well prepared for this test. You really should. If you haven't looked over your formula chart, just as another thought, just kind of look through it. Remember, we also have those 2 assignments I'd like you to have done on Monday. So thanks for watching. Enjoy the rest of your rainy time off. I know it's not the best spring break, but we could be in school, right? All right, we'll see y'all later. Have a good day.